Hi, welcome everybody to this session. My name is Gianluca Sartori, and I would have loved to deliver this session in person in London and maybe have a chat with you, have a coffee together, but the pandemic had different plans for us. So here we are. This year's SQL Bit sessions are all recorded and 100% online, but don't worry, we got this. Today's session is baking extended events recipes without breaking a sweat. A few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant and a data platform MVP. I've been working with SQL Server for almost 20 years. The first version I have worked with was version 7, so really a long time ago. Currently, I'm working as a DBA at a famous Formula One team in Italy. If you want to read my blog, you can find it at spaghettidba.com, and my handle on Twitter is @spaghettidba. So, the agenda for today. First of all, we will see why Trace is dead and why everything is about extended events now. And then we will go and describe the main ingredient for today's recipes, ICSI Smart Target. Don't worry if you don't know it, we will introduce it in this session. And then we will go straight to the recipes. Today we don't have demos, we have recipes for you. Okay, so first of all, Trace is dead. Why? Because Microsoft has been trying to replace Trace with something else for a long time. The first appearance of extended events was in version 2008, and it was introduced in order to be the foundation for a different feature, the SQL audit. And at the time, we had a very rough start for extended events because we didn't have all the events available in Trace. And we had to wait with version 2012 for that. And also, the tooling was not the best, and many people were a bit disappointed by extended events at the time, and they decided to stick with SQL Trace and Profiler. But nevertheless, extended events was very promising as a technology because it was a totally new way of capturing events, very deep inside SQL OS and with a lower performance overhead compared to a Trace. And also it had the ability to capture some events that were not available in Trace. Fast forward to today, and we still have extended events and things have improved quite a bit now. Well, SQL Trace in the meantime has been deprecated, and this means that it doesn't receive any additions from Microsoft, and it doesn't receive new events, and it's one of those features in maintenance mode. So this also means that all new events only get added to extended events, and we will never get an equivalent for SQL Trace. Also, if you are working with Azure SQL Database or Azure Managed Instances, your only option is working with extended events because you don't have the ability to start any traces there. So if you are working with Azure SQL Database, you can set up a session for extended events and save the events to Azure Blob Storage. You can do the same even with Azure Managed Instances, and you also have the ability to use the streaming API to receive the events in near real time. Also, I have to say that tooling has improved quite a lot in the meantime, and so SSMS has better UI for extended events and also has introduced some new features like Extended Events Profiler. Okay, that said, one of the things that is really important when working with extended events is not only which events to capture and how to set up sessions. We will not be discussing that in this session. I assume you already know how to do it, how to capture interesting events and how to configure sessions. But I would like to draw your attention to the targets. The targets is what receives the events and works with the events. And we have different type of targets here for writing to memory or to a file. We also have an event pairing target for those events that come in pairs, like like lock acquired and lock released. We also have event tracing for Windows when we need to pair events with those found in Windows. And we have two counter targets. One for counting the events, all the events that you throw at the event counter target get counted. And then we have a histogram target that is capable of grouping the events before counting, using one of the fields or actions as the grouping element. So this is really interesting what you can do with these targets, but there are some actions that are not available out of the box. Just looking at this list, I can think of writing to a database table. There's no way with the native targets to do that. And also, there's no way to run some alerts on top of your sessions. When you receive a specific event, in some cases it would be good to fire an alert. And we don't have a target for that. So this is why I created XC Smart Target. XC Smart Target is a free and open source project that you can find on GitHub, on my GitHub. So the address is github.com/spaghettidba/XC Smart Target. And this command line application has the ability to receive events using the streaming API for extended events. And these events are treated by some response types that will perform some actions in response to the events. And these actions are meant to be an extension to the capabilities of the standard targets. It is coded in a way that it can be configured with JSON files so that you will not be required to do any coding on your side, promised. And we have different type of responses for XC Smart Target that will perform different actions depending on how you configure them. So let's see together what's the type of responses that we have. We have one for writing to CSV files. We have one for writing to a table. This is one that I really wish was available out of the box in the standard targets. And then we have another version of the table appended response that is grouped table appended response, and this one will try to group rows together and summarize them by aggregating and grouping rows. And then we have a replay response that will extract the text from SQL batch completed and RPC completed events and try to replay those events to a target instance. Then we have email response that is capable of sending emails in response to an event. Then we have execute T-SQL response that is capable of executing an arbitrary T-SQL command in response to events. Then we have two response types capable of writing to non-relational databases. The first one is the telegraph appended response. This one is capable of sending the event data to Telegraph, which is the collection agent for InfluxDB, a non-relational database for temporal data. Then we have Guelph TCP response. This one is capable of writing to a Greylog database, a specialized database for logs. If you go to the documentation that is linked here in the slides, you will see all the available response types and what you can do with them, all the properties that you can configure in JSON files. Okay, so enough talking. Now we can go straight to our recipes. We have a lot to show today, so let's go straight to our recipes and start baking. I will use a notebook for this, a notebook in ADS, and I will give for each recipe a session that describes what we will capture, and then a configuration for XC Smart Target that will run responses in to each event. And then we will have to use some client applications in some cases to read the data. So the recipes are made of these three ingredients. First of all, I'm going to have to run this setup script. And if you want to run this notebook in your environment, remember to change the server name here and the path to where the demo files are stored. Okay, so let's go straight to the first recipe. In this case, I will want to write all the events to a CSV file to monitor what is happening on my SQL Server instance in real time. And this will do pretty much what we do when we start a session similar to what we get in Profiler, and write to a trace file and watch the data as it appears. Why am I showing you this? Because many people complain about extended events being complicated compared to Profiler. So now I will show you how it is super easy to start a session and capture the events with XC Smart Target. In order to start my first session, I will use DBA tools that contains the definition for many templates that were introduced in DBA tools by Chrissy Lemaire. And she coded a lot of extended events functions in DBA tools. And we also presented here at SQL Bits 2 years ago how easy it is to use DBA tools for your extended events work. So one of the things we can do is grab one of the available templates from DBA tools and use it as a starting point for running a session without having to write a single line of T-SQL for that. So if I want to see which templates I have available, I can run this. So I can run get DBA XC session template, and I will output that to a grid view. And here you can see that we have many templates available. The one that I will use is the one that you get when you start Profiler and you accept the standard template for Profiler. So I'm going to have to run this. I'm going to import that template to my instance, and I will run it as recipe 01 using the template Profiler standard. And then I am going to start that session. Okay, so now recipe 01 is started and it is running. Okay, so that was super easy. Now that I have a session with the equivalent of the Profiler standard session, I can start working with it using XC Smart Target. I could be using one of the built-in targets for this, and I could write to an XEL file, but this would use the storage of the server. What I want to do is use the storage of the client, so my client machine instead. That allows me to capture for a longer time. So now I am going to use XC Smart Target for that using a CSV appender response. As we said, we need to have a JSON file to configure how XC Smart Target works, how it will respond to the events. So let's go and see what a JSON configuration file looks like. So first of all, we need to have a target definition that contains the server name to attach to, the name of the session that will stream the events to our application, and then we can control many more properties like this one, fail on processing error. I set this to false so that it continues working even if one of the events triggers an error. But you can set it to true in order to stop XC Smart Target at the first error. And then we have a list of responses. Here we got a square bracket, so this means this is a list. And for each of the responses, you will have to provide the type. In this case, we are using a CSV appender response, which has a list of available properties that control how this response will work with each of the events presenting to it. So we will have to provide, in this case, an output file. This is one of the available properties. You can go and see on the documentation which properties are required or available for each response. The output file, in this case, I'm writing to ctemp, so be careful when using JSON files. Backslashes have to be escaped, so I need to put 2 when I have to put a single backslash. And I can control whether to overwrite or append to an existing file. In this case, I'm overwriting. And then I can choose which columns go to my CSV file. So I'm selecting name, collection time, and all these names are taken from the fields and the actions on the events that are treated by this response type. The events that I am working with are here in the list, so I can restrict the events received by this response, so processed by this response. And if you remember how the default profiler trace is composed, it has more events like existing sessions and logins and logouts. So we are not working with those, we are only working with RPC completed and SQL batch completed in this case. So that was super easy to configure. Let's go and see what happens when I start my XC Smart Target. I'm going to have to pass my JSON file as the configuration, and I can also specify where to write the log file. So when XC Smart Target starts, it says it is connected to the session recipe 04 on my server, and now I could go and see my file on VS Code. Let's try to start it. So I will go and start code, and this shows me the events written to the CSV file, and code makes it easy for us to visualize which columns are which using different colors. I could also use a preview here to show a grid with the events, and in order to refresh it, I would have to refresh this file again. But if I wanted to show you the data in the CSV file as soon as new rows are appended, I could use a different small application, which is called CSV File View. This is from Nearsoft. And if I run this, it shows me the file in this format. And I can also decide to allow multi-line fields and set this to auto refresh, so it will show me the data in my file as soon as new rows are appended. So I am achieving something like right into a file and watching it live with a single utility. So this is pretty nice, I would say. I'm going to go ahead and stop this, and I will also stop XC Smart Target, and we can go and start with the second recipe and do something more complex. Now we can also use XC Smart Target to write to a database table. It is possible to write events in T-SQL to a database table, but it involves two things that you probably don't want to do. The first one is shredding the data from the ring buffer of the session, and this is really something that I hate doing. I don't have any XML shredding ninja skills, so I try to avoid that as much as possible. Another possibility is to capture to an XCL file on the server and then use XC file target read file to read the contents of the file after the session has been stopped. But this actually requires you to stop the session. Otherwise, you will not be capable of reading the data from the file incrementally with ease. It is a bit complicated to do. So again, XC Smart Target has got you covered. This time we will use a table appender response to capture all the events. First of all, we will have to define a session to define what we are capturing. In this case, I will set up a session that records all RPC completed events and all SQL batch completed events. If you have a look at this create event session instruction, you see that we don't have any targets defined because XC Smart Target will be the target for this. Okay, so let's go back here. Let's go and start the session. Now it is running. And now using table appender response, I will write to a database table. Let's go and have a look at the JSON file for this. So again, we are connecting to a server, to a session, and we are using a table appender response. We have to specify which server to write the events to, the name of the database, and the name of the table. We can also decide to let XC Smart Target create the table automatically using the types of the .NET columns to decide which data type to use for the new columns. But this has the drawback of using safe data types. So this means that strings get mapped to nvarchar max columns, which is probably not exactly what you want to use. So I created this table up front in order to use the correct data types. Again, we are capturing RPC completed and SQL batch completed events. So what I expect here is that all the columns that I put in my output will be mapped to the columns of the table using the name of the columns to match it. And every event has a name and collection time properties that get added automatically. So name is the name of the event and collection time is when the event was fired. Okay, let's try and do this. I will start XC Smart Target, and now it is running, and it should be printing rows like this. Okay, it says 224 rows written to my table. Let's go and have a look. Do we really have any data in there? Let's go and see for ourselves. So I'm running this from SSMS, and actually we do have some rows, and they contain all the data. So RPC completed, and let's find some SQL batch completed events. So now you can see that we have different events that have different attributes. So here we have batch text defined for SQL batch completed events. and statement for RPC completed events. And it would be nice if we could put them on the same columns as we can do with SSMS in the Watch Live Data window. That one has the ability to create a merged column. Okay, so let's try to do the same using XC Smart Target. So I'm going to stop this one and I'm taking you to the next recipe. Before writing to a database table, we will merge and manipulate the data. So again, I will show you how easy it is to create a session using DBA tools. In this case, I want to use the same session that I had in the previous recipe, and I want to copy it to my instance with a new name. So I am going to get the session named recipe02. I will export it to a file and then import from that file using the name recipe03. And then I'm going to start it. So let's do this. And now I have recipe03 running on my instance. Okay, what about the configuration of XC Smart Target? Let's have a look. So now I have a JSON file that is a bit more complicated. I still have a table appended response that writes to recipe03 queries as the name of the table. But now I have some columns that are mapped to the event fields and actions directly, and two more columns that are defined as an expression. So I have SQL as statement. So RPC completed, we said it has the statement property, and we are going to rename it as SQL. And then we have a new column that we define as total IO as logical reads plus writes. And we are doing the same for the SQL batch completed event. We will use some properties directly from the event, and then SQL will be batch text. So batch text renamed as SQL. And then total IO is still logical reads plus writes. Okay, let's try and run this. So again, I'm going to have XC Smart Target, and now it is writing two sets of data. So this is RPC completed and this is SQL batch completed, and in 10 seconds we have more RPC completed and more SQL batch completed. Let's go and have a look in SSMS. So I will start this. We're going to read from recipe03 queries. And now we have RPC completed, and the statement property goes to SQL, and total IO receives the sum of two more columns. Let's go and find a SQL batch completed event. Okay, oh, I think I saw one. Okay, here it is. SQL batch completed. It has SQL that now contains the batch text, and total IO contains the sum of the two columns that I defined as the JSON file. So this is how you create a merged column and an expression using XC Smart Target. Great, so let's stop this recipe and let's go straight to the next one. This time we are going to capture blocking and deadlocking, and then we will send a notification using email to the DBA. Again, this is one of the things that you cannot do out of the box using the standard targets, but no problem, you have XC Smart Target for this. So first of all, we're going to have to define a session for capturing blocking and deadlocking. So let's have a look at the session. We are capturing the blocked process report event, and in order for this event to be fired, we need to configure also the configuration option blocked process threshold. I am going to set this to 10 seconds, so when this blocking time is exceeded, this blocked process report will be thrown. And then we have an XML deadlock report event. I will also attach some actions to it, like the client application name, host name, database name. So something that gives me the ability to understand where this event comes from. And I did the same for the block process report here. Okay, so let's start the session and see what we do with XC Smart Target. So for receiving notifications, I will not set up a real SMTP server, but I will use a tiny, nifty application which is called Papercut. This is very handy in all those situations where you need to troubleshoot or experiment with emails. This is a small application that has an SMTP server and an email client all collapsed into a single application. So it is an email client, or something that looks like an email client. Let's start it first. And it also has in the background an SMTP server that listens for connections. So now we have some deadlock events from a previous run of this session. And as you can see, it looks like an email client. So I'm going to have and delete these events. I will leave Papercut running in the background, and then I will show you what the configuration for XC Smart Target looks like. Okay, so we have two responses here. One is of the type table appended response, and it will write to recipe for deadlocking as a table using these attributes. This one, XML report, is the one that actually contains the deadlock report. So it is interesting to save it to a file, to a database table. We will do the same even for blocking, so we're going to have to use a second table appended response, and it will write to recipe for blocking, and it will also write the block process, which is the XML that contains the block process report. Then we also have an email response. This one will attach to an SMTP server on localhost and will write to DBA at localhost using this sender address. We can set the subject and the body, and then we can also add attachments to our emails. In this case, I will attach the XML report column that will be saved as a text file and attached with this attachment file name, so deadlock.xdl, and we will see how this shows up on the client. So we will start XC Smart Target with this configuration, and we also need to generate some deadlocks. If you are running your ERP software or your SharePoint, those are great for generating deadlocks, but I don't have any of those here, so I will have to use a script for my deadlocks. Okay, so we have XC Smart Target here, and it is writing to my tables, and also it is sending emails. So let's have a look. Oh wow, we got some emails here. Okay, enough deadlocks. Let's stop the deadlock generation. Let's go to Papercut. So what we have here is some emails that all contain this body. Oh no, we got a deadlock. But also, if we go to the sections, we can see that we have an attachment here, which is called deadlock.xdl. And if we double click it, we see that it contains the XML report of my deadlock. If I receive an email like this, I can double click my attachment and open it in SSMS and see the deadlock graph. So that's pretty cool if you ask me. Okay, let's stop XC Smart Target and go to the next recipe. This time we are still capturing blocking, but this time instead of just sending a notification, we will also kill the offending SPID. So imagine that you have a session that is blocking other sessions and it is idle. This happens when somebody starts a transaction, steps out for lunch and leaves a transaction open. Or maybe we have a poorly written application that doesn't close the transactions maybe when it receives an event, so the event is not treated correctly. In those events, it's advisable to kill the offending session. So we are going to need a session for that. It will use the block process report again. We still have to configure the block process threshold configuration option. So we will start this one. And now we are going to use execute T-SQL response in XC Smart Target. Let's have a look at the JSON file for this. This is pretty simple. We're still attaching to a recipe of 5 session on this server, and now we are using an execute T-SQL response. It will connect to this SQL Server instance and to this database name, and it will execute this T-SQL command. Here we are running a store procedure, kill blocker, and we will pass transaction ID. Here you see with the curly braces inside the script, we can use fields and actions from the event. So the transaction ID from the block process report will be used as a parameter to the kill blocker store procedure. We will do this only for the block process report events, and we will also filter only for the events that have been waiting for at least 20 seconds. Let's go ahead and do this. So we have XC Smart Target here, and we will have to create 2 idle sessions. So let's go here and create them. I will have a transaction here that I will start. I will update 1 row on the AdventureWorks 2016 database, and then I will try to read that row from a different session. And as you can see, this is blocked. So what will happen when the event is captured by XC Smart Target? It will go to this store procedure that I will show you. This one will receive the transaction ID that will be used to identify the session ID, and this will be looked up in DMXX sessions and requests to identify the blocking session ID. And with this speed, we will run the kill command and kill the blocking session. Let's see if this has worked. Let's go back to our SSMS, and oh, now it has finished, and it took 30 seconds. So this means that it was XC Smart Target that killed the blocking session. Let's see what happened to this, which was a blocking session. If I run this select one command, I should see a message from SSMS that tells me that this session has been disconnected. Let's try and run it. Yes, this connection has been closed. So XC Smart Target took care of the blocking session here. Good. So let's move to the next recipe. We will go ahead and audit logins for this recipe. So imagine that you inherit a SQL Server instance with many logins, and you don't know exactly which ones are used and which ones are safe to delete. You have many ways of doing this. You could enable successful and failed logins recording in the error log, but this would create a lot of noise in your error log. The file would become huge in the matter of minutes. So another possibility is to run an extended events session for capturing the login events and write them to a file target, but you would have to process that file afterwards. So we are not really interested in the individual events. We don't really want to know all the details about the login events. All we need to know is when a login last appeared on my instance. So in order to do that, we can use a group table appended response in XC Smart Target. It looks a lot like a table appended response, but it groups rows before writing them. We also need a session for that, so let's see what the session looks like. We will capture the SQL Server.logging event, and we want to also capture the client application name and the server principal name. Okay, so let's go back to here and start the session. Now it is running in the background. Let's have a look at what the JSON file for XC Smart Target for group table appended response looks like. So this time we still have something that looks a lot like the table appended response, but it is grouped. It still needs to know where to write the data, so server name, database name, and table name. But now for the output columns, we have some rows that are aggregated, and all the columns that are not aggregated will be used to group the rows in memory before writing to the target table, and also they will be used for merging with any existing rows with matching attributes, matching keys for these three columns. Okay, so let's go and try to run this. I am going to start XC Smart Target. Now it is running and it is writing data to my database table. Let's see what it looks like from SSMS. I can have a look at the contents of this table, and here I see that I have a single login here that appeared, but if I keep refreshing, I will see that more rows are flowing to this table, and the data is grouped by the first three columns, and these three columns, first seen, last seen, and long on count, are the result of the aggregation. So if I keep running this for a while, a meaningful amount of time, we'll see which logins are used and which ones are safe to delete. Great! So we can stop this and we can go to the next recipe. I will show you how to use a very similar concept to track which objects are used in the database and which ones are not. It would be great if we had this already in the documentation, but sometimes documentation is not up to date. So with extended events and with audits, we could capture all the individual events and write them to a file. But we have the same problem as before. We are not interested in the individual events. All we want to know is whether the objects are used or not. It would be great if I could use the audit events, but those are restricted for the audit feature, so they're not available for use. I will use the lock acquired events for that. So depending on the mode, it will mean I will get some reads or writes. So schema stability, intent shared, and shared locks are reads, and instead intent exclusive and exclusive locks are writes. So let's try to do this. I have some filters also on this session. Okay, so let's start the session, and I will use the group table appended response for this, but now I have one group table appended response that I will filter only for mode not exclusive and intent exclusive. So this means the reads. I can go and write to this table audit table, and I will use client application name, database ID, and object ID to group these columns, and I will aggregate the maximum collection time as the last read and the count collection time as a number of reads. I will do the same for the writes, so mode X and IX means the writes. I will use the same keys and I will aggregate collection time, the max as a last write, and the count as a write count. Having the same keys, they will go to the same rows when they match. So let's start this and let's try to capture that with XC Smart Target. So now it is writing to my database table. Let's have a look from SSMS, and I can run this, and I see that I have some tables that are being read and some tables that are being written to, and if I leave this running for a meaningful amount of time, I will know which objects are used in my databases. So again, I think this is pretty useful. Let's go to the next recipe. This one comes from an idea that gave me Brent Ozar with a blog post of his. So he wanted to know which users are using the most CPU. Brent used the resource governor for this, but I will use extended events for this. I will capture RPC completed and SQL batch completed events, and again I will use a group table appended response for that. So the session itself is pretty straightforward, RPC completed and SQL batch completed, but the magic is in XC Smart Target. So let's have a look at the JSON file. This time I will use a group table appended response, and it will use the snapshot ID as the first 16 characters of the date. So this means that I'm taking away the seconds. And using these columns to aggregate the events together, this means that I get a new description of my workload every minute. So I will have these columns summarized by the minute. So CPU duration, reads, writes, and the number of execution will be described over time. So let's go and run this. Let's start XC Smart Target. And as you can see, it will start writing to my database table. Let's have a look at the data I am capturing. Let's run the first one. As you can see, snapshot ID is limited to the minute. So if I leave this running for more than 1 minute, I will see more rows appearing here. And each row will have the key with the client application name, server principal name, and database name. And here we have CPU duration, reads and writes, and execution count by the minute. Let's see if we get to the next minute. You see the numbers are going up. And now you see that this will also be used to summarize the data. So now we should get some more. We are to the next minute, and we should see some data appearing. Here we are. So we have the next minute, and the data now is summarized using the new minute. If we visualize this with dashboarding software like Grafana, we get something like this. So let's open Grafana, and here you see that the data is flowing. Here we can zoom in and have a look at the last 5 minutes, and now you can have this summarized by login. So for each login, we can see CPU time, reads, writes, duration, executions, and we can also do the same by application. So the statistics for this application, we have duration, number of reads, number of writes by application instead of by logging. Okay, so this is pretty cool, I think. We can also use XC Smart Target to write events to an InfluxDB database. And InfluxDB is a temporal database. For this, we will use a session that captures block process report, error reported, and RPC completed events, also SQL batch completed with result equal to, so the timeouts. And these are good additions for a monitoring solution like the one you have with Telegraph and InfluxDB. If I start the session, I can use the Telegraph appended response that will need to have defined which measurement, so the equivalent of a table in InfluxDB, to write to, which are the tags, so the columns, and the fields, so the measures. And you can do that for different events like we have here for timeouts and for deadlocks and for blocking. So if we try to run this, and if we start Telegraph this time will take care of running XC Smart Target. And now Telegraph should be writing my events to an InfluxDB database. So we can go ahead and open the dashboard here. That should, we need to generate some deadlocks here, some events to capture. So now we can go and see what the dashboard for this looks like. We don't have any events here available, but if we zoom to the last 12 hours, we have some events here that were captured using this technique, and we have some deadlocks. We can expand this and see the number of deadlocks and the details. So on the database, the user, and we can click here and go to the details, so the XML report for the event. So I think that was pretty cool. We can stop the deadlocks again. And this was the last recipe for today. So let's go back here, and if you have questions, please go ahead and send me an email. Don't be worried, I'll get back to you, and I hope you enjoyed this session. So thank you very much, and don't forget to fill in the feedback. Bye bye, see you next time.